Today I'm in the workshop where I hope to kind of have a mess around with some linear motion. About a month or so ago, or a couple of months ago now, I spotted a really cool looking linear rail on eBay. This was a kind of a long linear rail with so this was a bar that attached to a flat surface and it had a coupling on the top, bearings in, and you kind of load it up and it allowed for smooth motion along. It looked really cool, but it was, I think, 60-70 quid to get it shipped over. And so rather than getting that, I found a load of other kind of related items which were all kind of go really quite cheaply, and bought a load of bits and thought I'd have a play. This is an area I've never kind of worked in before. I've never built anything like this. The closest I've got is the 3D printer build last year, but that was a kit. Obviously that has two sets of linear rails, kind of moving kind of horizontally, or kind of along and then sideways, and that has kind of a dull set of rails along with kind of a stepper motor setup which moved the bed kind of around. And so I thought I'd kind of take a look and see what I've got. So I'm just going to have a look at some of the bits here. So these are the parts I've got to work with today. I've got some 8mm kind of rod here. It's 40 centimetres long, and I've got two lengths of that. I've also got a load of kind of linear bearings here. These won't be used, but the same thing here is mounted inside these mounting blocks here. And so the shaft runs through, and you've got ball bearings on the side which allows it to be loaded from the side. So the plan is to build something like this. So the shaft sits down on the ground like so, and then this gets loaded and pushed down, so that can take quite a lot of force. So I've also picked up a few other kind of bearing parts here, which I'm not going to be using today. Those. The main parts of the kind of aim for today is to build a basic kind of rail or kind of linear movement system. So I have two rails running along here, a platform which will sit on the top, and then this will then get driven along sideways with this stepper motor. The stepper motor will run a timing belt all the way to the other side and to this mounting here. So I've got a basic bearing in here with a couple of washers separating it on a little 3D printed block. The stepper motor's on the other end in a little kind of 3D printed bracket. It turned out quite nicely actually, so I put that up on Thingiverse. The shaft supports here are going to be held up by these basic brackets. I was missing a couple, which is why I 3D printed a pair, but the correct ones, the missing ones, turned up the other day, so I won't be using 3D printed versions. And I've got a little SparkFun stepper motor driver to control it all. So I'm just going to lay out this as I plan to build it, and I'm going to cut a platform for it all to sit on. I tested the dimensions of the moving platform the other day just using an old bit of wood, and so once I had that sorted out, or the idea in mind, I've got these two pieces of acrylic, kind of laser cut. I'm going to stack together to form kind of quite a nice 6mm moving platform. I've got a slightly different arrangement of holes, because on the top surface I want it to be quite clean, so I've just got 4 holes in each corner, and a lot of the screws will be terminated in the middle, so I'm going to try and hopefully going to countersink a lot of these holes here. And so I will attach this first plate down to a lot of bearings and fixings, and then when that's done, put the final set of bolts through onto here, leaving a nice clean surface on the top. I've also got this kind of sticking out bit at the back. This will hopefully act as the kind of trigger the limit switches. This thing needs to know when it's reached the end, the motor can stop. So I'm going to mount 2 little micro switches, so as it moves along, it kind of hits and knows. So that was it's a bit of an afterthought, that one. It's not the best kind of way to do this, I don't think, but for this kind of test, which is effectively what this is, it's good enough. So this is the plan for the rig, a really kind of basic setup. Got the platform on the rails, and this will be mounted on a piece of wood, and this will then move back and forwards. I will be using this kind of timing belt that'll run along across the motor underneath around this other bit and attach this platform on either side. So obviously as the motor turns, this then gets dragged back and forwards. And we have a little kind of mounting point for the switches, like here. So as it moves along, it'll contact the switch before it hits the end, and it'll tell the system to then stop moving it, and likewise at the other end. And so I'm just going to mount this up kind of measure this now and get a piece of wood kind of cut and start mounting some of these pieces. For something like this, accuracy really isn't important. It's these the movement on this needs to be accurate, but once this bit's out of the way, which kind of determines the sizing, that kind of does its own thing. So this forces the dimensions to be kind of right. But the placement and everything else is kind of, it doesn't really matter too much. And so I'm going to be using this piece of MDF. This is an offcut I got from someone. It's I think it's probably high density fibre board or something like that. But it's really nice and will form a decent solid base. And so the parts, I've just kind of roughly laid them out, how they're going to sit. And for something like this, this is certainly for me, the best way of kind of getting dimensions and working out how things will look. So I need a little bit of space on this other side to mount the switches, but not a huge amount. So that, I think, is a reasonable distance. I can kind of mount little brackets in there. I'm envisaging 3D printing little brackets, very similar to these end stops here. Actually, is if I use these to represent that. So I have something like that with a little switch mounted on the side. And so one of those at either end. That doesn't look too cramped on that side, should be good. On this side here, the rail itself reaches the limit. Nothing's going to be hanging over. Yes, it's quite possible I'm going to have a larger device on here, which might bump into something, but I don't want to start planning for things which may never happen. I want to keep this fairly small and quite compact, so the placement of this roughly on the end there is perfect. A little bit of space again, just as a border. And back again on the other side, we've got a little bit of space for the motor. The motor kind of the shaft of the motor needs to be aligned with the centre for the belt to run through. Or it doesn't need to be, but for this case it does, because I've already got the holes mounted in the middle. So that's going to sit roughly there. The electronics for this, I'm seeing a really simple control. So all I want is a speed control, so a little potentiometer on there, and two buttons, a left and a right button. So you'd set the speed you want, and you'd set and press the right button and it'll travel over to the right. You press the left button, it'll go to the left and it'll stop. So I'm probably going to design and print a little kind of panel which would fit in there. And so at the moment, the best location for that seems to be potentially over the top here, but I'm a little unsure. Actually, if the motor mounts that way round, then I've got room in there for something. So I think if I plan to have things that way round, that gives me a little bit of space in there to mount a screen. So I'm going to cut this just along there, keeping the same kind of border either side, and a little bit of extra on the other side there, and that will be good enough for the platform. I'm starting to screw these bits down onto the board. It's really important at this stage to get the rails perfectly aligned, and rather than measuring them and working out that it needs to be 10mm separation between the two rails, I'm going for kind of a simpler approach, which I think is probably a better approach for a project like this. This first rail here I've screwed down. I'm just using wood screws for this, partly because it's easier, and it also means if I can use wood screws for everything, I don't need to put feet on this to keep it off the ground or kind of countersink any holes on the rear. I don't know if that's going to be a good idea, so these may need to be switched out, but for now, wood screws, it seems to be holding. So this first rail is secured, and so this can go anywhere, it'll move along. And I'm letting the setup here guide the placement of the other one. And so as you move this along, it's now in the ideal position for it to run the smoothest. If I was to kind of force this, bolt this down at the wrong angle, I don't know if you can hear that, it starts to grate and drag. It's no longer a smooth motion. So there's this little bit of play. When you hold down one end, the other end moves very slightly. But I'm hoping that's not going to be too big a deal. It is quite a small change. And now using this placement, I'll attach the first one, make sure it still runs smoothly, and then screw the second one down. Just about to put this end bearing or kind of bracket in place, and just quickly point out how I built this. It's by no means my own idea. I kind of half took it from the 3D printer I've got, and it's probably quite a common technique. But the other end, the belt needs to run around something. I could have used another one of these, little kind of toothed wheels, and kind of mounted that in a shaft, but it doesn't need that locking mechanism. It can run over a smooth surface. And so in the middle of here is a little bearing, which is one of these. Forgotten I think I've got a proper name, but it's basically an outer wheel and an inner wheel with ball bearings inside. And so that can take a lot of load and spins quite smoothly. In here and then in the side, focus, there are a pair of washers. There's a very small washer and there's a large washer on the side. The large washer is to stop the belts rubbing against the sides or falling off. And so if this was out, if this didn't have this bracket mounting in place, then it could obviously just slip off. So this larger washer prevents that. But if you push a large washer against the side of here, it's going to rub. Ideally you want it clamped to the inner shaft here. Then it'll rub against the outer and it won't spin smoothly. So if you put a smaller washer on first, that kind of just sits in the middle here, it gives a little bit of separation. And so you have the smaller washer in there that's separating it, so this large washer doesn't rub. And so you end up with a really kind of nice but very, very simple kind of smooth free running end bracket. I've got a slight problem with my original plan for attaching these two pieces of acrylic. I was going to use so you can see here, they've got 4 screws. These are going to come through and the rest are going to be hidden inside. I was going to use countersunk screws and recess them into this plastic, but I don't think it's going to work. For one, I've only got these kind of mushroom head screws to hand. I don't have any countersunk 4mm bolts to use, which is a problem. And 3mm, if I do try and countersink and set them in, I don't think there's going to be much left to grip to. So I'm going to go for an alternative option. What I do have is a lot of this acrylic, and so I'm going to cut a 3rd layer to go in the middle. Now this 3rd layer, I'm going to use the same design I had before, but expand the size of these inner holes. So I'm going to make these big enough to accommodate the full head of the screw. So there'll be another piece of acrylic which will sit over the top of this, and these kind of screw heads here can get hidden in the middle of it all. And I'm going to go and cut that now, and then I'll still get my original thing on the top. I've got a fairly smooth surface. Obviously I will still have these mushroom heads coming through. I may switch them out for some kind of sourced countersunk version, because there's not going to be a huge amount of load on this, so a small gripping area isn't going to be too big a deal, or I might do something else for that. But that is my plan for solving this problem. How perfect is that? Designed exactly as planned, fits over really brilliantly. And I also found these really nice little black countersunk 4mm bolts, which I'm going to use for this top part here. And so all that's going to be seen on the top is just these little recessed black bolts. See that? Fits over the top. The 3mm is more than enough space to hide the head of the screws, head of the bolts, and that'll be perfect. The next part of this project now needs to be done at home, where I've got access to the 3D printer. The butt is the next piece to go on, and this will obviously loop around the 2 ends and attach to the underside of here. So I need to design and print 2 clamps. I think I actually already found something on Thingiverse which might be suitable for this. So the belt needs to clamp to either side of here, and also have a tensioner of sorts in there to get it nice and tight. And when that's in place, I can connect up the electronics and give it a go. In addition to that, I can also take a look at the some kind of electronics panel for this end here to house the stepper motor controller and some kind of microcontroller as well to operate that. Okay, so I finally got this moving. The little kind of tensioner brackets I had printed out didn't quite work. The spacing of the holes wasn't right, and a variety of other problems, so it took kind of a bit of trial and error, but I've got some simple brackets clamping that on underneath. It turns out the pitch of this, the number of kind of teeth per inch, is much higher than on my on the 3D printer I've got, so it's nowhere near kind of clamped in, but it's quite straightforward to print a few. and that is now kind of set up and moving. I haven't installed the end stops yet, but this isn't skipping at all, so I'll be able to get it kind of moving quite reliably without that. So I started at kind of one end. I've got it set up so it kind of traverses and then returns again. That works fairly reliably. I'm not quite sure what the ratings are of the stepper motor and the SparkFun motor controller, but it gets very warm when this is running, so I don't think it's rated for this kind of load, so I will need to switch it out with something better. At the moment I'm just running this off a Trinket, which is running through a just slightly modified sample stepper motor program. Actually, it's really straightforward. And I'm running that from a lithium-ion battery pack. And so when I connect that up, it makes a funny noise, and then it starts off on its transition. I've got it running through, kind of traversing it at a higher speed, then returning at a lower speed, but it's moving through the same, I think, 1,300 steps in each time, so it kind of reaches the same level. And obviously this, because of the way it's set up, can take quite a bit of load. The only thing that will start to get overheated is the motor controller. And so that is it's really basic project, this. It's not hugely useful in its own right. You can put a camera on it and have a kind of a tracking shot as it moves along, which might be quite interesting, but it is purely just an experiment for me to kind of mess around and have a go using some of this equipment, and I'm quite pleased. So I think another fairly successful little project.